Hey everyone, today I'm super excited to bring you a new lecture on developing a hexagonal architecture inside of a NestJS backend. Now, a hexagonal architecture is a software design pattern that helps us to isolate our core business logic from external concerns and infrastructure like user interfaces, databases. So in this diagram here, you can see a quick look as to what the architecture we're going to build in this lecture, where in the center here sits our domain logic for our given application. And this domain logic is going to be encapsulated inside of our entities, which are going to be classes we create with their own data, and then methods that act on that data. So this domain logic is going to be the core of the app. It's going to be the single source of truth. And then to actually interact with this domain model, we're going to create use cases, which are essentially handlers for invoking the domain model. And finally, we're going to have ports, which are essentially interfaces that define how these use cases and eventually the domain model interact with the external dependencies, like the database, for example. And so these are simply interfaces. And then finally, we have these adapters, which are the actual implementation of these ports. So by developing our NestJS backend with this hexagonal architecture, we're going to be able to create a really loosely coupled backend that follows the single responsibility principle very well, and it's going to be really clean and easy to maintain as it grows in size. So I'm really excited to jump in and start building this NestJS backend with you, following this hexagonal architecture so you can take this away and implement it in your future projects to build scalable, maintainable backends that have a rich domain model that's really loosely coupled, meaning we can swap out our external dependencies like the database or other services without breaking the app or having to do huge refactors. So let's go ahead and see how we can jump in and do this. I'll see you there. So before we jump in, I want to let you know that the full version of this lecture is available on my website at michaelguay.dev, which includes an additional section where we go over integrating CQRS into our NestJS hexagonal architecture project. So head on over there if you want to get access to this full lecture. In addition, you'll get access to hundreds of hours of exclusive developer content here that goes into advanced topics on backend and front-end technologies. And you'll get access to all of my best-selling Udemy courses, including my latest one where we're actually building an Instagram clone with NestJS and Next.js, which is a really fun project. And we've already got about 8 hours of content in here, in addition to all of my other courses. So be sure to check this all out if you're interested in learning more. Thank you so much for giving it a look, and let's jump right into the lecture. So before we jump in, I just want to give a shout out to ILY2E1372, who actually recommended this lecture topic on YouTube. Be sure to leave a comment below or on my YouTube posts about content you'd like to see in the future. Let's go ahead and jump in. All right, so let's go ahead and initialize our NestJS project by using the Nest CLI to create a new NestJS project. If you don't have the NestJS CLI, you can install it with npm globally at nestjs/CLI at latest. So with the Nest CLI installed, we'll go ahead and initialize our new project by running nest new, and I'll call this NestJS hexagonal. You can call it whatever you'd like. And I'll use npm as my package manager to quickly install my dependencies. All right, so with our project set up, we can cd into it, and I'll open it up inside of a code editor. And so we have our basic starting NestJS application here with our main.ts file where we're running Bootstrap to initialize the project on port 3000. And we have our default app module with a starting app controller and app service. So this is exposing our HTTP traffic, a single GET route to return our get hello string using the injected app service. We can also go ahead and run in the terminal npm start dev to start up the development server. And so this will go ahead and start up the NestJS application, listen for any changes we make, and then we should be able to navigate to localhost 3000 where our server is listening on by default and see our hello world stub string. So this means our application is running successfully. Let's go ahead and see how we can now implement a hexagonal architecture inside of this Nest app. So to start off, we can actually remove our default app files since we'll not use them in this project. So let's go ahead and clean up our project by removing these files and their imports, as well as in the app module. So now we have just a blank empty project. Now with this hexagonal architecture, we're going to set up our directory structure in a way that is conducive towards this domain-driven design. And for this, I'm going to have a separate directory per core domain model. And that'll include all of the features, functionalities, and endpoints that'll access on that domain. So in our case, we'll have a users domain where we'll have any user-based functionality that acts on our user entity. So in this way, I'd create separate directories in source per domain model. So let's go ahead and start off with the user domain model, where we'll keep all our user-related functionality, domain models, value objects, ports, adapters, and use cases. Now we're going to walk through all of these different parts that make up our hexagonal architecture. Now there's going to be 4 key components to each domain model inside of our hexagonal architecture. So let's go ahead and create these. We're going to have the application directory, which is where we're going to keep our underlying ports and use cases, which we'll see how they fit into our architecture later on. So with inside of application, let's create a new ports. Now ports are going to be the abstract interfaces that define how the outside world interacts with our domain. So these are just going to be interfaces. We're also going to have use cases, which are really just an orchestration layer to actually make use of a given port through an adapter and then execute the functionality on that, as well as creating and managing our domain models. So now that we have the application directory, let's also create a domain directory. And so this is where we're going to keep our underlying domain models. So these are going to be the classes that make up the domain, which include entities and value objects. Now we're going to dive deeper into both of these in a bit. Let's start off by just creating the entities folder. So entities in our domain model are going to be really the core of it. It's going to be the user itself in this case. And so entities are objects in our domain model that have some sort of identity that has persisted over time, regardless of changes to their attributes. So these entities are also going to be mutable, which means that the attributes can change during the life cycle. So for example, a user, well, that user is always going to be the same user, even if their underlying properties change, like their email. They're going to have a core identifying feature like an ID, which determines its underlying identity. But the point is these entities are where the business logic of the domain is going to live. And that's because we can put functionality into these classes as well as the data around them. And a big benefit of doing this is that we're going to encapsulate our data, make it private, and allow access only through outside calls directly through the domain model. And so this is going to provide a number of benefits, including keeping all of our business logic centralized into a single place instead of spread out throughout our application. And it also will help us prevent bugs from mutating data inside of these objects. So we'll dive deeper into entities later. We also have the idea of value objects, which are simpler objects in the domain model that don't have distinct identities, but they're defined solely by their attributes. They're essentially immutable. So once they're created, their attributes cannot change. Value objects like the user's email and ID will be part of the domain model, but they won't have actual identity themselves. And so we'll create some of these later as well. So next up, we're going to have the infrastructure folder. And so in this directory, this is where we're going to house the actual adapters to our hexagonal architecture. And so adapters are a key component, which are going to be the actual underlying implementations of the ports that we define, which is going to actually contain the functionality defined inside of the ports, which are the contracts or interfaces that express the functionality we want to expose to our underlying clients. And so we're keeping the actual implementation here decoupled from our abstract definition. This is going to keep our application very loosely coupled and follow the dependency inversion principle, because these adapters are going to depend on an abstract interface. And then the code itself will also depend on that abstract interface, which we can swap out at any time. So it gives us this layer of flexibility in the application. And so we can have multiple adapters or implementations of the ports that we define. And so we'll see examples of this as well. The last directory I want to create is going to be the presentation directory. And so in here, this is going to be essentially where we have any consumers of the hexagonal architecture, the features within, and the domain model. So this, in our case, is just going to be an HTTP controller, but it could also be gRPC or any transport layer or any client implementation like a UI. And so in our case, we're just going to expose a single HTTP controller that'll expose all the functionality we want inside of this architecture. All right, so now that the basic outline of one of our domain models in this hexagonal architecture is set up, we're ready to actually start creating our application. Now, I think the best place to start is with the domain model itself by creating the entities and value objects that we're going to be working with. And this is also going to show us the benefit of using this hexagonal architecture since we can utilize this domain-driven design. So let's go ahead and start off by creating our user entity inside of entities directory. And so this is going to be an export class user. And we'll have a constructor where we take in all of the properties that we need to create a new user. Now, before we do this, I want to set up some value objects that are going to be utilized inside of this entity, this user entity. So recall, since this is an entity, it's going to have a persistent identity. It's going to be mutable. However, these value objects are not. They're going to be simpler, reusable objects without any identity that are immutable after they're created. So in our case, I want to create a couple of value objects. Let's firstly create one for the user's email. So I'll create email.vo.ts and another value object for the user ID, which is actually going to be identifying feature of our user entity. So let's start off with the user. So let's start off with the user ID value object. We'll export class user ID. And so I'm just going to declare a single private read-only value that will be the underlying value of the user ID inside of this value object. And so it's read-only because this is immutable. Once it's created, it won't change. So we can also have a custom constructor where we pass in an optional ID if we have one. And so we can check to see this dot value is equal to the ID that's passed in, or we can implement some business logic here and say, for example, we want to set a default user ID using random UUID from Node Crypto. And this is the first bit of business logic that we're now abstracting into the common value object, which is already showing some of the benefit, right? Instead of having to set the random UUID every time we create a new user ID everywhere in our code, well, now this logic is centralized into this one spot in the value object itself. And we're also hiding the data inside of the object, which is another key feature of this domain-driven design, because since this value object is immutable, we'll be immune from a lot of bugs that occur in production when properties on objects are mutated at runtime and makes it very hard to debug. Well, thanks to this data hiding, we're never going to change this value after it's set. We can actually expose custom getters here, so we'll have a get value that returns this dot value back to the caller. And since this is a primitive value, this is going to be a copy, and the actual underlying value here is never going to change. We can also have a custom equals, which can get passed in another user ID. And so we can check for value comparison. If this dot value equals other dot value, well, that's how we know this value object. So now our first value object is complete. Now make sure we actually move this to the user ID value object. I'm in the wrong file, and resave it. So now the user ID is complete. Let's move on to the email value object. So we'll go ahead and again export class email. And this will be a very similar implementation. We'll have a private read-only value of type string, which is going to be the underlying email itself. We'll have a constructor that can pass in an email. Let's say we require one now because we're not going to auto-generate this. And we can now have some more business logic here in the constructor. We can actually validate the email that gets passed in. So we ensure that every email in our entire application always meets our validation. So let's create this private is valid functionality that takes in an email and returns a Boolean. We can check our validation here. So here you could implement strict email validation with a regular expression. In our case, for simplicity, I'll just do a basic check and see if email dot includes an @ sign. So we'll say that this is our business logic for a valid email. And now in the constructor, we can check if this dot valid and pass in our email. If it's not, then we can throw a new error and actually have invalid email format error. Otherwise, we'll go ahead and set our value of the email that got passed in. Let's lastly go ahead and also implement get value. So this will return our string value, and this is simply this dot value, which is the email. And we'll also have another equals method. The other is of type email. And all we have to do is, again, compare this dot value to other dot value. So now our email value object is ready to go. We have some encapsulated business logic as well as the data itself. Let's finally go back to user entity and start filling it out now that we have the value objects we need. So for the user, let's accept all the properties that we require when creating a new user. The first one will be the read-only ID of user ID type. So now we're explicitly going to import our value object and set that equal to the ID. And so this is really useful because now we actually have both the data encapsulated here in the user ID value object to protect it, as well as the business functionality on it, so that we don't have to pollute our user entity with a bunch of business logic that's not really related to the user itself, but instead its underlying properties. That's the power of these value objects, in addition to the data encapsulation. So then we'll go ahead and add the properties that make up the user. So we have a name, and notice we're setting them to private to hide the data, as well as set our class level properties. We'll accept the email type now, which is another value object. And let's say we'll also have a private read-only created at date and updated at. So we want to keep track of these properties for auditing purposes. And now we have the constructor complete for a new user. All right, so now that our domain model has the data associated with it completed, let's go ahead and add some business logic in the form of methods on this entity. And that's going to interact with the data that we have associated with our user instance. So the first thing I want to do is create a new static method to actually create a new user entity, because we're going to have some business logic associated with the creation of a new user. So we can have a new static create method that we can call on the static user class. And so create is just going to take a new name and email as strings for the new user that we want to create. And then we can perform some business logic on this. So we can say if the name was not passed, or if the name.trim.length is less than 2 characters. Well, let's say we have a special business logic rule that says we want to throw an error and say name must be at least 2 characters long. So we can perform any sort of validation we want with the data associated with creating a new user, and this is all centralized. So now if we know the data is in the shape we want, we can create a new user and return it back to the caller and pass in the parameters that the constructor expects. So we'll create a new user ID using our value object, which will assign a default one using our UUID function. And then we'll call name.trim to trim the name that we pass in. We'll then pass in the email value object and pass in the email string in the constructor, so it gets set and passes our validation. And finally, for created at and updated at, we'll set these as new dates. So we're essentially centralizing the logic for creating a new user entity inside of this static method. And so now we can create new users. This is great. Let's go ahead and add some more functionality on the user entity. The next thing we want to do is create getters for the underlying data inside of the user. And this is so that we can return the data back to our presentation layer through our HTTP controller, or if we had separate clients that wanted to consume the data inside of the user. Well, we're setting this all to private in order to make use of our data hiding. So we need to set up some getters that we can actually return the data associated with our entity. So let's go ahead and add these now. I'm going to go ahead and add a getter for each of our user properties that we want to return back to callers. So the first one will be for the ID, and then we return the actual data on the object. So in this case, we can return back the ID value object. Go ahead and do the same thing for the name now. Let's go ahead and do it for the email. And lastly, we'll have two more for getCreatedAt, which will return back a date instance and return back this .createdAt. Let's do the same thing now, finally, for getUpdatedAt. Well, let's say we want to support user updates. So for example, we want to allow the user's name and email only to be updated after creation. So let's create some new methods to allow this data to be mutated. So we'll have an update name method, takes in a new name of type string and updates the user entity name. So we can go ahead and apply the same validation as earlier that checks if the name passes our business logic, meaning it is a length of greater than 2. Otherwise, we'll go ahead and throw that same error that we had earlier inside of static create and go ahead and set the name to the new name and set this .updatedAt as well. So this will ensure that whenever an update to the user occurs, we always update the updatedAt property in unison with it. So we're centralizing this business logic. Let's do the same thing for update email. That will pass in the new email. And now we can simply set this email equal to the new email, pass in the email string, and just as we've done before, let's reset this .updatedAt to the newest date. Now let's say we want one more method on the user entity that tells us, for example, how old the actual user is using our createdAt date. And so for example, we want to keep this logic in one place and return it back to all of our clients so they don't have to perform that same calculation whenever they're accessing the user and want to know how old the user actually is inside of the system. We can centralize that logic and perform it once here in the domain model using our encapsulated data. So let's create a new getAccountAge method, which will return back a number. And so we'll check in here. Well, first we'll get the current date and use a new date. And now we'll have a diff time to get the difference between the absolute value of the now.getTime, which is the milliseconds value of the now date, and then subtract this from this .createdAt.getTime. And this will give us the difference in milliseconds between the two. Well, in this case, let's say we want the final unit of time to be in days. So we can return math.ceiling, which will return us the upper value of diff time divided by 1000 times 60 times 60 times 24. And this will give us the number of days that the user's account is old. But now we have a basic domain model set up on our user entity with some business logic. Let's go ahead and now start adding use cases to actually invoke some of the methods we've created on the user domain model and then eventually expose it in our presentation layer with an HTTP controller. All right, so now that we've encapsulated our business logic inside of our domain model, it's time to start building out some ports to introduce some external dependencies to our application. And by following our hexagonal architecture, we're going to insulate this new dependency from the domain model where our business logic sits, which is going to let us swap it out at any time with ease. So in this example, we want to use a simple repository pattern to model a database. And so this repository will be responsible for actually creating and reading new users into our system. So this is where we would plug in our database layer using some sort of ORM. However, by creating a port for it, we're going to be able to swap out the implementation for the database at any time. So let's go ahead and inside of application ports, we'll go ahead and create a new user.repository.port.ts. And so a port is simply the interface that describes the contract that we're going to adhere to inside of this external dependency. And this is what will allow us to swap it out at runtime. So we'll export interface user repository port. And now we'll define all of the methods that we want to exist on this external dependency. So the first one will be save to persist a new user to wherever this port is saving it to. Now this could be a database, it could also be in memory to a file, really anything that adheres to this contract. Well, we're going to pass in a user entity into the save method, and we can directly reference our user entity from our domain model. So we'll pass in that user, and we'll return a promise with the created user returned back to us. We'll also have a find by ID method that'll take in the string and return back a user by looking them up by their ID, or null if no user was found. We'll also go ahead and have find by email that takes in the email and will return us back the user, or type null. So we can look a user up by both of these. We'll also have a find all that returns back all of the users that we currently have saved. So this will be an array of users. And finally, we'll have delete to allow us to delete a user by their ID. And we'll return void from this. So now we have the port complete and essentially have the contract for this external dependency. So at this point, we're ready to create an adapter, which is going to be a concrete implementation of this abstract port. So to do this, let's head back into our infrastructure directory where we're keeping our adapters. And now we'll create a new adapter. So this will be any implementation that adheres to our port. Like I said, this could be an actual database with any ORM. Or in our case, we want to implement a simple in-memory user repository that will just save and fetch the users from our local memory. And so this will be very easy to do with our hexagonal architecture. We can just create a new in-memory user.repository. And so we keep all of our different uses of this port, the adapters inside of this directory. Would have one for our ORM and any other implementations we have so that we can swap them out whenever we want. So let's go ahead and create this class in memory user repository. And this will then implement our user repository port to make sure we adhere to all of the methods that we defined on that interface. So we can also mark this as a NestJS injectable class so that we can inject any dependencies that we might need, and we'll wire it into our module later on. Now we can see here our TypeScript is already telling us to implement all of these methods. So there's another benefit is that we'll always have a type-safe set of methods defined on each of our implementations because we're implementing the port. So let's go ahead and start off by firstly defining a users map where we're going to store the users that we're persisting to our in-memory repository. So this will be a map with a string key, the user ID, and the user entity itself being stored. And we'll set it equal to a new map to start. We can also go ahead and set this as read-only. And so now we're ready to implement our in-memory repository methods. So let's go ahead and start off with our save. And so we'll pass in our user entity and make sure we update our imports. And so now we'll go ahead and save the new user to our users map by calling this .users.set, pass in user, and now we can use the getID getter function on our user entity to get the ID and then set the user on the map. Now recall, since this user ID is a value object, we have to use the getValue function that the value object is returning to us. Lastly, we'll go ahead and return back the originally saved user. Now let's go ahead and also update our port to be able to support non-async, because in this in-memory, we have no use for async await since everything is in memory. So we'll just update our return types here to also expect non-promise based types. And so now back in our in-memory user repository, we can remove the async. And now we have save implemented. Let's go ahead and implement find by ID, and we can have this autocomplete for us. Let's go ahead and simply return this .users.get, get the user by their ID, or if no user was found, we'll return null. We also now have find by email. So let's go ahead and get all of our existing users by calling array.from and then pass in this .users.values to get all the values of our map, which is all the user entities themselves. And then we can find inside of the array. So we'll call users.find. And for a given user, we can now use the user dot get email equals the email that was passed in. Make sure we call get value on the email value object, and then also update the return type to be null if the user is not found. And so now lastly, we'll have find all, which will simply return array.from, and again call this .users.values. So now we have the users returned. And finally, we'll have our delete, where we'll look up the user by their ID and remove them. So for this, we'll simply just use this.users.delete, pass in the key, which is the user ID, and now we have the full contract implemented on our adapter for the in-memory user repository, implementing the user repository port. So this is great. We're now ready to finally wire this together by implementing a use case which actually orchestrates the needs of the presentation layer by bringing together our adapters and domain model. So let's go ahead and do this next. All right, so let's get started with our first use case for our user domain. We're going to create a new create user use case to be able to actually create a new user through our domain model. So we'll create the create user.useCase.ts, and this is going to be an injectable class. So we'll go ahead and export class create user use case. Here we're going to need to get access to our NestJS dependency injection system to actually inject the underlying ports, or rather their implementations, our adapters. So we'll go ahead and set this up next when we wire together our hexagonal architecture into the NestJS dependency injection system. Let's go ahead and add a new async execute method. Now we'll also go ahead and define the DTO or data transfer object for this underlying use case directly in this file. Feel free to separate this out if you'd like. We'll keep it in the same one for simplicity. So we'll have our create user DTO interface, which contains the properties needed to actually invoke the underlying use case through our domain model. So in this case, that's going to be the name and email of the user that we're trying to create, which are going to be the properties that we will require. So now we can reference the DTO parameter in the create user DTO. We'll go ahead and return a promise with the user entity return type, which is the newly created user, back to our presentation layer. So now we need to actually create the user, and to do this, well, we know we have our user repository port defined. We need to actually wire our underlying adapter that adheres to this port, which is our in-memory user repository, into the NestJS application. To do this, inside of the user directory, we're going to add a new user.module.ts file, and this will be our NestJS user module, where we'll go ahead and wire together the pieces of our hexagonal architecture. So I'll export class user module and go ahead and decorate this with @module from NestJS common. So now inside of our user module, let's wire together our NestJS providers, which will mark our underlying classes as singleton instances that can be injected inside of our NestJS app. So in here right now, we just have the create user use case that we're currently in the middle of creating as a provider, and that'll give it access to the dependency injection. Now importantly, we now need to define the underlying adapter as a NestJS provider. So in order to register it as a custom provider, we need to create a injection token, which is just a simple constant value that we can reference both in the provider's definition as well as in the injectable classes where we want to inject it. So to do this, I'm going to keep this inside of our existing user repository port. So in here, let's go ahead and create this new const user repository. This will be the injection token that we'll use, and so we can use the JavaScript symbol and pass in a simple string called user repository to make this a unique value that we can keep as a constant. And now in the providers array for the user module, let's go ahead and create a new custom object where we have the provide parameter. This is for a custom provider. Now we'll reference that user repository injection token we just created, and then say use class to provide the singleton instance we want to use as this provider. And so in that case, that's going to be the in-memory user repository that we created earlier, which is our underlying adapter. And so now with this change in place, well, firstly, go to the root app module and make sure we import the new user module so that it's tied into our Nest app. And with this in place, now we're actually going to be able to go back to our create user use case and inject the custom providers that we set up. To do this, we'll go ahead and use the @inject parameter decorator from NestJS common that allows you to provide the injection token for the injectable instance you're trying to inject. In our case, that's the user repository token we created and used in the custom provider definition. And so this will be a private read-only user repository. And now we can use the user repository port as the definition of this injectable provider. And this is really the magic of our hexagonal architecture, which helps to make sure our application is loosely coupled, because now inside of this use case, we're simply going to be referencing the user repository port, which is this abstract interface. And at any point, we can actually swap out the underlying implementation by providing a different provider for the user repository token without having to change any of the code inside of the use case, because the interface remains the same. Now you might see a type error here about some issue with isolated modules. If you do see this, make sure you go to your TS config for a project and let's set isolated modules to false, and this should resolve the type error with inside of the constructor. And now we can see that we have the user repository injectable ready to use to actually create the user. So let's go ahead and do it. So inside of execute, I want to first check to see if there is already an existing user by this email, because let's say we want to have a unique constraint. So we can keep that logic here inside of the create user use case by using the user repository and calling our find by email method, pass in the dto.email, and do a check to see if we already have an existing user. Then we'll throw a error saying user with this email already exists. Otherwise, we're going to go ahead and create a new user by using our user entity. And recall we have our static create method defined, which is responsible for managing the business logic around the creation of a user, which is a great benefit because we're not going to have to duplicate that logic inside of this use case. And we're also not going to have to pollute it with this other responsibility of creating a user, keeping our code with more of a single responsibility. So we'll pass in to the new user the dto.name and dto.email. This will create the new user, perform our basic validation, and now we're ready to save it inside of our repository. So we'll go ahead and get access to the saved user, which is the created one, in case there's any post-processing applied. And we'll call this .userRepository.save and pass in the underlying user that was created. And now we can simply return back the saved user. And now we fully implemented this create user use case utilizing our abstract user repository port injected with our in-memory user adapter. And we also used the user domain model to create the underlying user. So this is great. We're ready to finally test this out by creating our presentation layer, which is simply going to be an HTTP controller in this case, to execute this use case and be able to test out our user creation. Let's go ahead and do this next. And of course, we have a small typo here, so make sure we check to see if there is an existing user. So get rid of the exclamation mark at the beginning of this check. Now for the presentation layer inside of our users directory, this is where we're going to create our HTTP controller to actually expose our application to a client. So let's go ahead and create the new user.controller.ts, and we'll annotate this with @controller decorator and give it the user's prefix. So go ahead and export class user controller. Now we'll go ahead and add a constructor where we can use our dependency injection. And now I want to directly inject the create user use case, which, since we set up as a provider earlier, we can inject directly into our controller. And so we know this is where we actually execute the logic to create our user entity and then persist the database with our in-memory repository adapter. So now we'll go ahead and create a new post route and call this create user. We'll also just mark this as async in the case that we had an external database that we wanted to await. And now we'll also extract the request body with the @body parameter decorator. And we can use our create user DTO that we defined earlier inside of the use case file. Now I want to go ahead and extract the user back from our await this.createUser use case, and now we can call the execute method on it, pass in the underlying DTO, and that will create the new user and return back the newly created user. And now what I want to do is actually map a response back to the client using the domain model that the user returns to us as the user entity, because there's some additional properties, like for example, how old the user's account is, that we want to format back in the user response instead of just returning the user entity directly. So to do this, I'm going to create a new private map user to response method. You could pull this into a separate service or function if you'd like. For simplicity, we'll keep it in the same controller. So this will take in the user entity, and we can import this as well from our domain directory. And now given a single user, well, this will depend on whatever the needs of the client are. So if the client expects that we have additional properties that the domain model can calculate for us using the business logic we encapsulated inside of the entity, well, that's our chance to do it here, and that's exactly what we want. We want to format a response based on the needs and encapsulate all that business logic inside of our domain entity. Now let's go ahead and return back the response for a given user entity. We'll say we want the user's ID. So let's call getID to get the value object and then get the value. And then we'll do the same for the rest of the get properties on the user. So we'll add get name and go ahead and continue this for all of the existing getters on the user entity. So I've gone ahead and also added the user's email, and we'll also add our created at and updated at properties. But let's say we now want to also expose an additional property on the user response, which is the account age, because we need to display this in the UI. Well, we can simply use the domain model here by calling user.getAccountAge to return that back. And you can imagine that we would do this for any additional properties we need on the client, encapsulating all that business logic, which is great. So now that we have the ability to map the user entity to a response that the client needs, let's finish off this controller route by calling this.map user to response, pass back in that user. And now at this point, the controller should be ready to actually create a new user over this HTTP post route. Make sure we go back to the users module and add a controllers array where we then add the user controller. And then make sure you've started up your development server. So you can see here we now have the users post route mapped. Let's go ahead and test it out now inside of Postman. So in Postman, I'll launch a post request at localhost 3000/users. And let's update the body to be a raw JSON body. And so we know we need to pass in that email. And we also need the name for the user. So I'll just pass in my name. And now you can see that the request was successful, and we're returning back these properties that we've extracted from the domain model, which is excellent. Let's go ahead and continue on by adding the rest of our use cases that'll use all of the methods we've defined on our user repository port and expose that through our user controller. Okay, so let's go ahead and create the rest of our use cases for our user CRUD functionality. So back in our application use cases, we'll go ahead and create the next one for getting a single user. So I'll just call this get user use case.ts. So just like we'll follow in the rest of these use cases, these are all going to be injectable classes. So we'll go ahead and export this class, and just like we did for the create user use case, we're going to have the same constructor signature with the user repository port injected with our in-memory user adapter injected with the @inject decorator. So go ahead and add these imports. And now for our execute method, let's go ahead and add an ID of string as a parameter we take in, and then we'll simply return this.user repository find by ID and pass in the user's ID. So also don't forget to go back to the user module and add the get user use case to our providers array. So we'll finish up with adding the delete, list, and update users functionality. Let's go ahead and start with the list users use case. So this will be to retrieve all of the users in our database. This will look very similar to the single get. So let's just paste in the get user, update the name to list users, And now in execute, we will call find all instead, and we don't need to accept an ID parameter. So go ahead and update the providers array again. Next up, let's do the delete users use case. So we'll create the delete user.useCase.ts. This will look similar to create user actually. Let's copy create user and paste in, update the name and remove the create user DTO. So this will be delete user. And now inside of execute, instead of the entire DTO, we'll just accept the ID of the user we're trying to delete. And we'll simply call await this.user repository and use the delete method on this port, pass in the user ID, and now they should be deleted. Lastly, let's go ahead and implement our update user use case.ts, which is going to have some custom functionality, which looks similar to start off as the delete user. So let's copy delete user and paste it into update user. So we'll go ahead and change this name now to be update. So we have the user repository injected. And now for the execute method, we need the ID of the user we're updating, and then a DTO object, which signifies the properties we're trying to update. So I'll export a new interface, update user DTO, and we'll have the properties that will be allowed to pass in to be updated. In our case, we'll say that all of the properties can be updated. So now we'll go use the update user DTO inside of execute. And the first thing I want to do is get back the existing user. So let's reach out to the user repository, which we know we'll find by ID. Pass in the ID. So if the user doesn't exist, then let's throw a not found exception and say user not found. Otherwise, we'll go ahead and check to see if we have the DTO name. Then we want to issue an update using our entity by calling user.updateName, which we know will take in the new name. So we'll pass in DTO.name. And that'll take care of the business logic of setting the last updated at property and more. And we'll go ahead and do the same thing for our email property. So we'll call user.updateEmail and pass in the DTO.email. Lastly, we want to persist the updated user to the database. So we'll call save on the user repository, pass in the updated user entity, which will have its properties updated, and return back the newly saved user. So now we have all of our use cases complete. Make sure we've gone to our users module and added the new delete user and update user use case. And so now at this point, our use cases are all complete. Let's head back into the user controller and expose the rest of this functionality over an HTTP route so we can test it out. So let's go ahead and create a new @get route, which will take in the user's ID that we're trying to retrieve by a path parameter. And so we can do that in NestJS with the colon and then the name of the parameter we want to call it. In this case, we'll call it ID. And so that'll represent the API like /users123, where the 123 is the ID we're extracting. So this will be the async get user method. And we can extract the path parameter with the @param decorator. Pass in the name string from the parameter name here, so that will match ID. And so this will be the ID string value of the user we want to retrieve. Well, now at this point, we need to get access to the use case just like we did for create user, where we know the logic for this operation lives. So let's inject get user use case now. And we'll set the create user use case to read only as well. And so now we can use this by firstly getting the user from the use case. So we'll create a const user equal to await this dot get user use case, call the same execute with the ID of the user that we're trying to retrieve. Now to turn back the same user response that we mapped to earlier, we want to call this dot map user to response and pass in the user we fetched. And so now we have the ability to retrieve a user by their ID and make sure we've called the execute method on the use case. Now notice we also get a type error here saying that the user type cannot be null. And this is because in our get user use case, we don't have a check on whether the user was found. So let's do this by checking to see if there was no user. Then as we've done, we'll throw that not found exception. and say user not found. And then only here, if we have the user, then we'll return it, and that should satisfy our compiler, because we can then go ahead and explicitly type this as a promise with a return type of our user. Also, don't forget the await on the user repository. So now we can see we have the get user implemented. Let's go ahead and see that the route has registered it in our logs. And now in Postman, if I go ahead and recreate a user, because remember it's in memory, so it'll wipe out each time your server restarts, well, we can now make a GET request at our user's API and make sure we paste in the ID that we copy from the newly created user response, paste that into the URL, and now we can see that we can actually retrieve the user back from our in-memory user repository, which is excellent. Next up, let's go ahead and add the GET route for listing all users. So we'll call this list users. This won't need to take in any parameters because we're going to retrieve every user from the system. So we'll go ahead and add our list users use case now. And so for this, we'll go ahead and retrieve all the users with our call to await this.listUsersUseCase.execute. And so now that we have all of the user, we'll go ahead and simply map the response and call map user to response and pass in the user to transform all the users into our expected client response. Next up, we can add @delete and extract the ID again with a path parameter. So we'll have delete user, and we'll extract the ID with the param decorator. So we'll have the user's ID of type string, and now let's get access to the delete user use case. And so at this point, all we have to do is call await this.delete user use case.execute and pass in the user's ID to trigger the deletion. Finally, let's go ahead and finish up with @patch for our user ID update. So again, we'll extract the user's ID with path parameter, update user, and so we'll go ahead and extract the path parameter user ID, and we'll extract the request body, which will contain the update request. So we know this will be of type update user DTO from the use case, and we can simply return, well, let's get access to the final use case, the update user use case. And so with this injected, we can now use it by calling this.update user use case execute and pass in the ID and request body. Lastly, don't forget that we need to await this call so that we can transform it into our client response inside of update user. So let's go ahead and now return this.map user to response and pass in the user from the update call. We can see the logs are okay. Let's head back to Postman and finish up the testing. So after I create my user once again, we can go ahead and pull it back by its user ID. So make sure we've updated the user ID. Again, this changes each time your server restarts. I can also call get and get back all of the users in an array here. Or we can launch a patch request to update. So let's pass in /users and then the ID. And let's say I want to change the email now to Michael2. So now you can see my user's email here was updated with the patch request. And finally, if I send a delete request, well, it's a 200 OK. Now if I try to get back all the users, it's an empty array at /users, as we'd expect. So now our CRUD API is fully implemented, showing the power of our hexagonal architecture as we're separating out the infrastructure, the database in this case, from the domain layer so that all of our domain logic sits inside this user entity, which is encapsulated. All this business logic only sits in one spot, as well as hiding our internal properties, which is a great practice for bug-free code. So this works great out of the box. However, you may have noticed that in our user controller in the presentation layer, our constructor is getting a little crazy here, and this is only implementing a few routes. You could imagine in large applications, if we're following this hexagonal architecture, we have so many use cases and our constructor fills up with all of these different use cases. It gets a pain to manage. Well, NestJS actually offers a solution to this by implementing its own variant of CQRS and domain-driven design with its own library. So CQRS, command query responsibility segregation, is an architectural pattern that separates data writes, commands, from data reads or queries. And NestJS allows us to essentially have a message bus that we can use to emit different events, and we can actually tie these use cases in to this as event listeners, and it's going to help decouple our application even further and make sure that we don't have to have bloated constructors like this whenever we want to add new features to our application. It's a much more elegant design. So in the next part of the lecture, let's go ahead and jump in to see how we can set up NestJS CQRS. So if you'd like to take this project even further and see how we can integrate CQRS into it in order to reduce our coupling even further and keep our application following the single responsibility principle, head over to my site, michaelguay.dev, where you get access to the full lecture and hundreds of hours of exclusive developer content. Thank you so much for watching this lecture, and I'll see you in the next one.